Hi students, welcome back to our online chemistry classes, and now we are continuing our lesson structure of atom. Now our next topic is valency. So before learning about valency, we should know some other terms. First one is valence shells and valence electrons. So according to Bohr's model, we have learned that there will be different orbits are there, K, L, M, N, etc. So if there is only one shell, if it is only K shell, for example hydrogen, we have written the configuration of hydrogen like this. That means there is only K shell. Then this is the outermost shell. This is the outermost shell in this case. So when we have written the electronic configuration of sodium, electronic configuration was atomic number was 11. So its configuration we written as here 8. So 2, 8, and here in M shell we have written 1. So this is the electronic configuration of sodium. So in this sodium, which is the outermost shell is M. M is the outermost shell, and if one more it is there, we have to draw N shell. So which is the last shell? That is known as outermost shell. Outermost shell in science or in chemistry we will call them as valence shells. Valence shell is the last shell, outermost shell. Outermost shell is known as valence shells. And the next point we should know is valence electrons. What is valence electrons? The number of electrons present in the outermost shell. The number of electrons present in the outermost shell is known as valence electrons. So now you have understood what is valence shell and valence electrons. Valence shell is the outermost shell. Valence shell is the outermost shell, and valence electron is the number of electrons in the outermost shell. And next one more thing we have to know, what is that? Octet or duplet configuration. According to previous configuration, we have learned that if there are 8 electrons in the outermost shell, or in the second point while we have learned the rules of writing the electronic configuration, it was learned that there will be 8 electrons in the outermost shell of an atom. So why there will be 8 electrons? Because if there are 8 electrons in the outermost shell, those atom will be highly stable. Those atom will be highly stable. So if there are 8 electrons in the outermost shell, that type of configuration is known as octet configuration. What is its name? Octet configuration. If there are 8 electrons, that is known as octet configuration. We know what is the meaning of octa. Octa means 8. In the electronic configuration, if there are 8 electrons in the outermost shell, that type of configuration is known as octet. The atoms with octet configuration will be highly stable, and there is only one element that is having high stability even though it does not have 8 electrons. What is the name of that element or atom? That is helium. Helium, it is a second element, and helium has only 2 electrons. That's why it will be highly stable. That means it has only one shell. That shell is completely filled. Due to that reason, helium is highly stable. So that configuration is known as duplet configuration. Duplet configuration. So if you are seeing that only few elements have this property. Which property? Octet configuration. That means remaining elements, they try to make the electronic configuration of the nearest these elements. What are these elements? They are helium, neon, argon, krypton, xenon, radon, etc. So elements, these are the elements which are highly stable, or they are also known as noble gases. Remaining elements, they try to make the electronic configuration of these elements either duplet or octet. All the remaining elements, they will try to make the either octet configuration or duplet configuration. So hope these things are clear. So in our textbook there is a table given. A table has been given in your textbook. So in that table it is given a serial number, atomic number, name of the element, its symbol, and number of protons, number of electrons, number of neutrons, and electronic configuration. And last there is a column given valency. So what is valency? Valency is the combining capacity of an element. We have learned this definition in our previous lesson. That means in atoms and molecules we have learned what is valency. We said that valency is the combining capacity of an element. Now we are going to learn valency in terms of electrons. In the terms of electrons, what is valency? So valency, we can say that valency is the number of electrons shared, lost or gained to get the octet configuration. So once again, in terms of electrons, valency is the number of electrons shared, lost or gained to get the octet configuration. Through an example you will understand it clearly. So we said that only these many atoms or these many elements having high stability. Remaining elements try to get the stability by getting the electronic configuration of these elements. That means they are trying to get 8 electrons in their outermost shell, or they want to get the octet configuration. To get the octet configuration, what the arrangement they need? They have to share the electrons, or they have to gain the electrons, or they have to lose the electrons. So in the case of, let us go through the tables. Detailed table is given in your textbook. Here randomly I have selected only few elements. So if you have understood one or two, you can get clear idea, and you will get all the configuration or all the valency of the elements given in your textbook. So first one, hydrogen. We are familiar with hydrogen. So how many electrons are there in hydrogen? Only one electron. That electron goes to K shell. Okay, and one more thing you have to note, that this hydrogen, it is not stable now. To get the stability for hydrogen, what is required? There should be either 2 electrons or 8 electrons, which is easy here. To get the 8 electrons or 2 electrons, here it is easy to get 2 electrons. To get the 2 electrons, hydrogen atoms, they will share. So as hydrogen atoms share 1 electron, to get 2 electrons they have to either get 1 electron or they have to share 1 electron. So only 1 electron they are sharing, so their valency is, last column we can write valency. Their valency will be 1. So valency of hydrogen is 1. Now let us come to helium. What about helium? Helium atomic number is 2 and there are 2 electrons. So 2 electrons, in which orbit it can accommodate? It can accommodate in K shell. So we know there will be 2 electrons. As there are 2 electrons, they are stable. There is no need to do any arrangement. There is no need to share any electron. There is no need to gain any electron, or there is no need to lose any electron. So what will be its valency? Its valency will be 0. There is no need to share, gain or lose the electron. Now let us go to carbon. Atomic number of carbon is 6. So let's write the electronic configuration of carbon 2, 4. K shell there will be 2 electrons and L shell there will be 4 electrons. See that to get the 8 electrons, what they need? Yeah, in the case of carbon, they have to share 4 electrons. They have to share 4 electrons to get the stability. So valency of carbon is 4. Now let's come to oxygen. Number of oxygen is 8. So given here, atomic number of oxygen is 8. So its electronic configuration is 2, 6. So there will be, in K shell there will be 2 electrons, and L shell there will be 6 electrons. So think that how can oxygen get 8 electrons? So if it wants to get 8 electrons, it has to get 2 electrons. When it gets 2 more electrons, it will become 8. So by gaining 2 electrons, it has to get 2 electrons. So how many electrons are gained here? 2. So its valency is 2. And in the case of silicon, its atomic number is 14, configuration is 284. So outermost shell, if there are 4 electrons, so they have to share the electrons. If there are 4 electrons in the outermost shell, they have to share that electrons. That means 4 electrons to get the octet configuration. Next one, sulfur. The configuration of sulfur, it is 286 because its atomic number is 16. 286. So there are 6 electrons in the outermost shell. How can they get 8 electrons? Yeah, obviously by getting 2 electrons. So its valency is 2. And chlorine. In the case of chlorine, electron configuration is 287. So how can this is the outermost electron or valence shell electrons. Valence shell, there should be 8 electrons, then only it will get the stability, and here to get 8 electrons it will require 1 more electron. That means it has to gain 1 electron. And in the case of argon, the configuration is 288. So outermost shell, how many electrons are there? 8 electrons. So there is no need to gain or lose or share the electrons. So if there are 8 electrons, its configuration will be 0. Hope these things are clear. By knowing shell electronic configuration, we can find the valency of an element. And very easily we can say that, very easily in tricky way we can find out it easily. What is that? If the number of electrons is more than 4. If the number of electrons here, we can see here it is 4. If the number of electrons is more than 4, what we have to do? We have to do 8 minus that. So if there are 5 electrons, 8 minus 5, 3 will be its valency. If the number of electrons is up to, if there is 1 electron in the outermost shell, 2 electron in the outermost shell, 3 electron in the outermost shell, or 4 electron in the outermost shell, then this 1, 2, 3, 4, this will be the valency. For example, sodium configuration is 281. How many electrons are there in the outermost shell? 1. So its valency is 1. And in the case of magnesium, it is 282. So what will be its valency? 2 is the valency. In the case of aluminium, it is 283. Atomic number of aluminium is 13 and the configuration is 283. So what is its valency? 3. So in this way we can find out valency. If it is more than 1, for example oxygen, it is configuration is 2, 6. It 6 is more than 4. If it is more than 4, what we have to do? Just we have to subtract from 8. 8 minus 6 is equal to 2. So 2 is the valency of oxygen. In this way very easily we can find out the valency of different elements. And a brief table, it is given in your textbook. Don't forget to read it, and you can go through it and you will get clear regarding the valency of different elements.